Good day everyone, I am Jazel from BS IT 1B. So before we proceed to our main point of this video, let's define first what is QUICKSORT. QUICKSORT is an in-place sorting algorithm. This QUICKSORT is a divide and conquer algorithm. In QUICKSORT, the partition of the list is performed based on the element called pivot, which divide arrays into two halves in such a way that, first, all elements to the left of pivot are smaller than the pivot. Second, and all elements to the right of pivot are greater than or equal to the pivot. QUICKSORT pivot algorithm. Based on our understanding of partitioning in QUICKSORT, we will now try to write an algorithm for it. In QUICKSORT algorithm, partitioning of the list is performed using following steps. Step 1. Choose the highest indexed value has pivot. Step 2. Take two variables to point left and right of the list excluding pivot. Step 3. Left points to the low indexed. Step 4. Right points to the high. Step 5. While value at left is less than pivot, move right. Step 6. While value at right is greater than pivot, move left. Step 7. If both Step 5 and Step 6 does not match, swap left and right. Step 8. If left is greater than right, the point where they met is new pivot.
Hello guys, I am Jane of Fletcher from BSIT 1A. For today, I am going to explain to you how to arrange unsorted list element by using QUICKSORT. Compare list left less than list pivot. As it is true, increment left by 1 and repeat the same. Therefore, left will stop at 8. Nanong nag-stop? Compare list right greater than list pivot. As it is true, decrement right by 1 and repeat the same. Right will stop at 2. Nganong nag-stop si right sa 2? It's because right is greater than pivot. Here, both left and right are stopped. Left is not greater than right, so we need to swap list left and list right. So now, we are going to swap list left and list right. Compare list left less than list pivot. As it is true, increment left by 1 and repeat the same. Therefore, left will stop at 6. Compare list left less than list pivot. As it is true, increment left by 1 and repeat the same. That means left will stop at 6. Compare list right greater than list pivot. As it is true, decrement list right by 1 and repeat the same. Right will stop at 4. Here, left and right are both stopped. Left is greater than right, so we need to swap list pivot and list right. Here, we can observe that all the numbers from the left side of 5 are smaller and the right side are greater. That means 5 is placed in its correct position. Repeat the same process on the left sublist and the right sublist to the number 5. In the left sublist, as there are no smaller number than the pivot, left will keep on moving to the next and stops at the last number. As the right is smaller, right stops at same position. Now, Left and right are both equal, so we swap pivot with right. In the right sublist, left is greater than pivot. Left will stop at the same position. As the list right is greater than list pivot, right moves towards left and stops with pivot number position. Now, left is greater than right, so we swap pivot with right. So, this is the final sorted list elements.
Hello, my name is Roseman J. Villanueva. My topic is demonstration on how QUICKSORT's algorithm works. In many cases, QUICKSORT is one of the most efficient sorting algorithms. To do a QUICKSORT, you essentially pick one of the values in the array at random. Move all values larger than it, above it, and all values below it lower than it. The value that you pick initially is called pivot. You continue on recursively picking a pivot in the upper and lower section of the array, sorting them similarly until the whole array is sorted. Now let's do this in action using these cards. First we need to do is to select a pivot. The convention is to pick the last element as your pivot. Our first element is larger than our pivot, so we need to move it behind the pivot. However, we're doing it an in place sort, so we need to move the element in front of the pivot to make room. So in this, we're moving 8 to the last, 2 to the last to the second part, and 10 all the way up to the first block. So we did our shift, and now we can make another comparison. Now we get to take a look at 10. Since 10 is bigger than 2, we need to, again, move 10 back, move 2 up, and move whatever in front of 2 up as well. Finally, we have 0 at the front of our array, which is actually smaller than our pivot of 2. Now we just move to the second element and do the same process with that one. Since 3 is greater than 2, we'll need to shift around everything again. Since 7 is still bigger than 2, we need to do another comparison though. At this point, we normally do the same process for everything smaller than the pivot and everything bigger than the pivot. Let's start with the smaller part first. Since 0 is actually less than 1, there's nothing we need to do. Now in the second half of our array, we select a pivot. Since 7 and 3 are both smaller than the pivot, we won't need to move them. However, 8 is bigger than the pivot, so we'll need to do a swap here. Now that our swap's complete, we can see that 8 and 10 are actually in their eventual positions. Everything less than 8 was already below it, so we didn't need to move it at all. Now we only have 2 elements left that maybe need to be sorted. Again, all we have to do here is to assign 3 as a pivot and compare. And the 7 and 3 already switched, then our whole array is done.